Okay, in this video, we're going to look at basically speed time graphs or velocity time graphs. Velocity and speed are almost the same thing, okay? They still have the same units. They both measure meters per second or kilometers per hour, maybe miles per hour, something like that. But the difference being that velocity is what's known as a vector quantity, and vector quantities have direction attached to them. So the velocity will tell us the direction that something is going in as well. Okay, so it's just not something I want you to worry too much about right now. We'll come into it in a bit more detail in a while. So the first thing we want to be able to do from this is be able to describe an object's motion from a speed-time graph, and then be able to use the speed-time graph to calculate something called acceleration and the displacement, and then we'll go for the average speed as well at the end of it. Okay, there's quite a lot in this. But before we get started on this, first of all, speed-time graphs have loads of information in them. They contain absolutely loads of information. The first thing they can tell us about is they can tell us about the speed for the whole trip. The second thing they can do is, using the velocity time graph, we can tell whether something is accelerating or not, and we can usually calculate it. And the last thing that we can figure out from it is the distance traveled or the displacement. Now, if you remember, I mentioned that vector quantities, vectors have a direction attached to them. So displacement is just like distance, but it's got a direction attached to it as well. So it tells us, again, just a tiny bit more information than just distance. Okay. So the first thing I want to talk about really quickly is acceleration. So acceleration is defined as the rate of change of speed or velocity. Okay, more specifically velocity. So again, we talk about something as having a direction here when we mention the word velocity instead of just speed. And an object can be accelerating in three different occasions. Number one, it could be speeding up. Number two, it could be slowing down, and we usually call this deceleration. And three, it could be changing direction. Okay, so this is where the vector part comes into it, because once it changes direction, then it now accelerates a bit more. Okay, so there's an equation for acceleration, and I've shown it just here. So acceleration is basically change in an object's speed divided by the time taken to change that speed. Okay, and what we'll see is in a little while is that we'll be able to calculate the acceleration from a velocity time graph or a speed time graph from the gradient or the slope of the graph. Now, if you remember, the slope of the graph or the gradient of the graph is just the rise divided by the run. Okay, rise divided by the run. But of course, there's another way of calculating acceleration too by using a formula. Okay? So we've got an acceleration formula, and that's this one here. So acceleration is the final velocity. V stands for the final speed or the final velocity, minus u, which is the initial speed or the initial velocity, divided by t, the time taken to go from one speed to the next speed. Where a is the acceleration, t is the time taken, v is the final speed, u is the initial speed. Okay? So I'll come to all this when we're doing the problems on the graphs, but right now, let me just bring you to the kind of information that is contained within a speed time graph or a velocity time graph. So first of all, you could have a situation like this, where the velocity is 0, or the speed is 0, and that happens when you get the graph. The graph appears on the time axis itself. It should be down at 0. Okay, that's when it tells us it's 0. So not to be confused with the distance time graph. When we had a flat line on the distance time graph, that gave us a speed of 0. For a velocity time graph, it's a little bit different. It actually has to read 0 for it to be 0. Okay. The second thing that it could be is it could be a flat line, but it could be up a little bit like this. So maybe this is maybe 5 or 10 meters per second here. And this would be a constant speed, okay, or a constant velocity. And the last thing that we get is when we've got a sloped line like this, one with a gradient on it, okay, and this one would be acceleration. Okay? So like we mentioned, acceleration, velocity, displacement, they're all vectors, so they all have direction attached to them. So if the line comes up like that, straight, then that's a positive acceleration. If it comes down like this, then that's a negative acceleration, also known as a deceleration. Deceleration. Okay?